Welcome to Vignyanguru. This is sixth video of flight lesson. So I'm facing a problem here. My beaker broke when I was trying to do a chemistry experiment. Luckily, I have a solution. Behold, the glassing liquid. This is simple to use. I'll just put the broken pieces into the liquid. Yes. Okay. Few more. And now, okay, let me stir this a bit. And magic! Now I have a brand new beaker as it was before. Okay, of course, this is a magic trick. But we also know that every magic trick has a simple explanation. Want to know what's the explanation of this? See the video to know the explanation. Hello friends, this is sixth video on light lesson of class 10 CBSE physics section. In the last video we understood about refraction. So what is refraction? We understood that when light travels from one transparent medium to another transparent medium, it changes its direction, and the change of direction is visible by its bending. It bends because it changes its direction. That's what we understood in last video. So in this video we will understand why it changes its direction and how it changes its direction and how much will be the change when it travels through different mediums. Okay. So first let us understand how light changes its direction when it is incident on a glass slab at different angles. So what will be the change? The bending will be same at all angles, or it's going to be different for different incident angles. Okay, let us see the activity. So I have drawn a thick straight line over a sheet of paper which is placed on a table. I have placed a glass slab obliquely on the line. You can see that at the edges the straight line appears to be bent. This is because when the ray of light transfers from one medium to another, it appears to be bent at the edges. Now I will keep it exactly at the 90 degree. Now the line appears to be straight. Now let me change the angle again. As the angle changes, ray of light appears to be bent. Let me try the other direction again. Yes, it looks bent. So through the activity, what we understood that when the ray of light travels from air to glass, it bends through different angles according to the angle at which it is falling, and it goes straight when it is kept straight, when the ray of light is exactly straight. So let us analyze these things scientifically. So let us understand some terms also. So the path through which the light moves in the first medium is called as incident ray, and in the second medium it is of course called as refracted ray, and the angle the incident ray makes with the normal is called as angle of incidence, and that refracted ray makes with the angle normal is called as angle of refraction. You know these things already. Earlier it was called as angle of reflection in case of reflection. Here it is called as angle of refraction. Now let us further go one step more and try to understand why this thing happens by doing an experiment with a glass slab, wherein we will be able to learn many more details about this. Okay, materials required are pencil, ruler, the protractor, glass slab, rectangular one, and few drawing board pins. So I have fixed a white sheet of paper on a drawing board with the help of the drawing pins. Now I will place the glass slab in the middle. Okay, now I will mark the boundary ABCD with a sharp pencil. Now I have removed the glass slab. Let us make the edges thicker. let us name it ABCD. So now using the protractor I'll mark 90 degree, that is normal, and then I'll mark 60 degree. 60 degree I'm going to calculate from 90 degree, so 90 minus 30, that is 60 degree. Now I am going to draw the normal, which is 90 degree line, join it, and then a 60 degree incident angle, 30 degree incident angle. Okay. Now I am going to put drawing pins over the line. I'm going to place the glass slab, and I'll try to look at the reflections of these pins from the other side of the glass slab, okay, by closing one eye. Okay, when I see this side, I can see that these two pins are arranged exactly at straight lines. So I'll just see the position where it is exactly at straight line. I'll put these pins. Okay, now I will remove the glass slab and all the pins. Try to join all the points now. Okay, now I will try to join all the points using a ruler. So yes, I have to join GH to CD, and I also should draw a normal in order to measure angle of emergence. So I will name it as O, that side as O and this side as O dash. So I will join O dash. Okay. Now I will extend O dash to meet the edge CD. We can see that the light ray has changed the directions at O dash, and both are at the intersection of two separating media. Let us check incident angle. So let us measure angle of incidence. Let us name it as I. So as we have drawn it, we know that angle of incidence is equal to 30 degree. However, let us measure it using a protractor. Of course, yes, angle of incident is equal to 30 degree. Now let us, yes, 30 degree. Now let us measure angle of emergence. Wow, great! Angle of emergence is also equal to 30 degree. So angle of incidence is equal to angle of emergence is equal to 30 degree. So we can see that light ray at point O has entered rarer medium to denser medium, that is from air to glass. So light ray has bent towards the normal. At O dash, it has entered from glass to air, that is from denser to rarer. So the light ray has bent away from the normal. So EO is the incident ray, OO dash is the refracted ray, and O dash H is the emergent ray. Let us extend EO to meet the other edge. So let us use the dotted lines. So we can observe that the emergent ray is parallel to the direction of incident ray. So that means the extent of bending of the ray of light at the opposite parallel faces AB and CD of the rectangular glass slab is equal and opposite. So that's why the ray emerges parallel to the incident ray, but there is a shift to sideward. How much is the lateral shift? Yes. So let us measure the lateral shift and write down. So after going through the experiment, we understood that when light travels from one medium to another medium, it changes its direction. It might be because there is a change in the speed of light when it travels from one medium to another medium. Why do there is a change in the speed of light when it travels from one medium to another medium? Okay, let us try to understand. So when light travels through one medium, each particle of the medium should absorb the light and then it should re-emit the light. And some mediums do this very quickly. They absorb and re-emit very quickly. And those who do it very quickly are called as optically rarer mediums. Example, of course, our air and vacuum, wherein there are no particles of the medium, it travels the quickest. And some mediums, they take time in absorbing, re-emitting, and they are called as optically optically denser mediums. Example, our water and glass, all these are called as optically denser medium, wherein the light travels little bit slowly compared to the air and vacuum. So we understood this part. Let us come to this experiment. Let us try to analyze what happened in the beginning. In the beginning, light was traveling from air to the glass. So air, as you know, from rarer medium to denser medium. In the air, the light was traveling very quickly as it is rarer medium. Now it encounters an interface where it has more number of obstructions. So of course it has to slow down. When it slows down, it results into change in the direction of the light. When the direction of the light changes, of course it cannot go straight, it has to bend. And which direction it bends? Of course it bends towards the normal. So if our normal is like this, it will bend towards the normal. Now, if it bends towards the normal, you can see that the angle of incidence is more than the angle of refraction. Let us try to take the another end of our experiment where the ray of light travels from glass to air. Here in this case, what happens? The ray of light is traveling from denser medium to rarer medium. So it was traveling slowly. Now once after coming to the rarer medium, it will travel very fast. So again when it has to travel faster, again it will result into bending of light. Now in this case, it will bend away from the normal. So here the angle of incidence will be less than angle of refraction. So these are the two cases which we discussed. So we understood that nowhere angle of incidence will be equal to angle of refraction as in case of our reflection. The reflection, what used to happen? Angle of incidence is equal to angle of reflection. But actually there is only one case wherein I will be equal to angle R. Which is that case? Yes. When the ray of light is incident exactly on the normal, exactly at 90 degree, it will pass through, ray will pass through without any deviation, without any bending. So it is only in this case angle of incidence will be equal to angle of refraction. Okay, so these are the three cases which we need to know. So let us go to some laws. Do refraction has any laws like we had in reflection? Of course, refraction also has two laws, two traffic rules, how the light has to travel when it has to encounter some medium. So what was the first law? First law of refraction is same as first law of reflection. So the incident ray, the refracted ray in normal to the surface which is separating two media all lie in the same plane. You understood, like you have studied for the reflection, all these three lie in the same plane. And the second law is ratio of sine of angle of incidence to the angle of refraction is constant for a given pair of media and for a given wavelength of light. So what does this mean? So second law means, so angle of incidence divided by sine of angle of incidence divided by sine of angle of refraction is equal to a constant. That means angle of incidence, sine of angle of incidence will depend on a sine of angle of refraction, and that will be constant. Wherever you do an experiment, that value will be constant, and that constant is called as refractive index. So we understood second law of refraction. So what is second law of refraction? Sin I by sin R is equal to constant. This is also called as Snell's law. So sin I by sin R is equal to constant. That constant is nothing but refractive index of second medium with respect to first medium. So what is this refractive index? We know that light when light falls obliquely from one transparent medium to another transparent medium, it changes its direction or it bends. And this bending is expressed in the form of refractive index. That's all. So refractive index denotes how much the ray of light bends when it travels from one medium to another medium. Okay. And we also know that this refractive index can be linked to the speed of light. How? Because this bending or the change in the direction of light is because of change in the speed of light. So refractive index can also be linked to the speed of light. So we can express it like this. Let us take the example which we just finished. What is that? When the ray of light travels from air to glass. So refractive index of glass with respect to air is equal to speed of light in air divided by speed of light in glass. So this refractive index doesn't have any unit. It's a unitless, dimensionless quantity. Okay. And this refractive index can be calculated in two ways. One is called absolute refractive index and another one is called relative refractive index. So what is absolute refractive index? If we to calculate refractive index, we need two mediums, right? If either one of the medium is air or vacuum, then we call it as absolute refractive index. Okay. So when is the speed of light maximum? Yes, of course, it is maximum in vacuum. Why it is maximum in vacuum? Because there are no particles to absorb light and re-emit. So speed of light is maximum in case of vacuum, and it's little bit more than speed of light is little bit less than vacuum in air. But for all practical purposes for this chapter, we assume speed of light in vacuum is equal to speed of light in air. Okay. So when we know that that's a constant which is represented by C and the value is equal to 3 into 10 to the power 8 meter per second. So if when we are calculating a refractive index, if we use one medium either as vacuum or as air, then we are calculating absolute refractive index. Let us take the example which we had done earlier. Okay, there ray of light was traveling from air to glass. Let us try to calculate the absolute refractive index of glass with respect to air. So we can calculate absolute refractive index, right? So mu is nothing but refractive index. Mu of air with respect to glass is equal to speed of light in air divided by speed of light in glass. And speed of light in air is represented by, as I told you, C, by speed of light in glass can be represented by V of G. So this we can take as a formula to calculate the numericals. Okay. So mu of glass is equal to C by V of G. So where is this useful? Let us assume that we know the refractive index of glass, that is nothing but 1.52. And we already know the speed of light in air, that is nothing but 3 into 10 to the power 8 meter per second. So then easily we can calculate speed of light in glass using these two. Oh, you have to solve many numericals on this using this form. Okay. Now let us go to the second type, which is called as relative refractive index. So relative refractive index is refractive index of one medium with respect to another medium, wherein both the mediums are neither vacuum nor air. Okay. So we can write it like this: mu of second medium with respect to first medium is equal to speed of light in first medium divided by speed of light in second medium. Okay. So let us again take the example of same glass, but let us say now the ray of light is traveling from water to glass. So the first medium is water and the second medium is glass. And now the relative refractive index of glass with respect to water will be speed of light in water divided by speed of light in glass. So this is the formula to find relative refractive index, but normally we use absolute refractive index for all practical purposes. understand why do we need to study this refractive index? Do we have any uses of these refractive index? Yes. Refractive index actually tells us how much a ray of light bends or how much it changes its direction when it travels from one medium to another medium. Okay, and we will also know whether it will bend towards the normal or whether it will bend away from the normal. Let us take the same example. We know that the refractive index of water is 1.3 and we also know that refractive index of glass is 1.5. That means the ray of light can travel quickly in water compared to glass. So when the ray of light travels from water to glass, it actually blends. Speed of the ray of light reduces, so it bends towards the normal. In this way, refractive index is very useful. This is all about refractive index.
Okay, I told you that I'll tell you the trick behind the magic. It's just simple. I had already placed the small beaker inside the big beaker, and this solution is not a glassing solution, it's just cooking oil. Okay, so then why this small beaker was not visible? That is because refractive index of the big beaker and the oil and the small beaker all were same. So the light did not bend, but of course it went into a straight line. So all of them looked merged together. So then you might ask, what happened to the glass pieces which I had put inside? See, I can show you, they are still inside. See, I can remove it. So now I'll show you how I kept the beaker inside. So now you can see that as it slowly goes inside, the part which is inside becomes invisible because of same refractive index of oil and the beaker.
So in this video we understood all about refractive index and the formula to calculate refractive index and all. In the next video we will study more about the lenses. Okay. So if you have any doubts, please feel free to comment in the comment section. Click the bell icon for updates and thank you for watching the video.